pretty top-notch at predicting solubilities at this point. Yes? You kicked butt on the quiz. So I want you to write down two things. I have sodium bicarbonate, NaHCO3, and I have, oh no, that's not what I wanted. Scratch that one. Sorry. I have ammonium acetate, NH4 CH3OO. COO. So I've got ammonium acetate and I've got copper nitrate, copper 2 nitrate, CuNO3 2 times. So write those two down. Just jot them down. Huh? Copper nitrate. Copper 2 nitrate. Okay, so I'm going to add a little bit of the ammonium acetate to this test tube. I'm sure nothing bad will happen, right? Just a joke. No, nothing bad will happen. That's fine. And since I don't have a pipette, I'm just going to mix this in like this. Okay. Now this is blue. This is still blue. Did it get cloudy? Thank you, ma'am. Did we form a precipitate? Okay, we did not. It's all drain safe with a little bit of water. Okay, so we did not form a precipitate. I know what I really need, but I don't have it. We could have predicted that. So let's write those two. Well, first of all, let's talk about what happens when we mix two chemicals like that. So we had CuNO3 2 times plus NH4 CH3COO. What kind of reaction are these two things likely to undergo if they undergo a reaction at all? Think back to your categories of reaction: synthesis, decomposition, single replacement, double replacement. Yeah, these would, and typically double replacement reactions happen when you have two, usually ionic compounds in aqueous solution and you mix them together. So, we don't seem to have had a reaction. Why? First of all, can you predict the products of this? Can you predict the products of a double replacement reaction? Who are the new dance partners? Sure you can. It's been a little while, but, you know, remember we're going to take the positive ions and the negative ions and swap places with them. Oh, that didn't show up at all. So what we end up with is CuCH3COO 2 times plus ammonium nitrate. So NH4NO3. And we'd have to balance this, of course, like that. Okay. So we didn't get a precipitate out of this. Well, what do you, from back to thinking about reaction types and evidence of chemical reactions, what does it mean when a precipitate appears? That we have formed an insoluble compound. Well, guess what? We now have the ability to predict solubilities, which we didn't have before. We couldn't do that before. Now we can. So what I want you to do is, and you can use your quiz, look up copper acetate. Is that soluble? Copper acetate soluble. What about ammonium nitrate? Is that soluble? Yeah. Well, guess what? Both of our products are soluble. Would we have a precipitate? No. We can predict the formation of a precipitate because what we do is look at the potential products of a double replacement reaction. If one of them is insoluble, we get a precipitate. If they're both soluble, nothing happens. We just have still ions in solution. That's the whole trick, and that's what gets you the final step close to writing net ionic equations. So, you just did it. Now let's think about one. Okay, let me give you another one. So if I have calcium chloride plus sodium carbonate, will I get a precipitate? So we've predicted the products, and now we just need to ask ourselves if they're soluble. Is calcium carbonate soluble? Billions of little sea creatures scream, "No, it's not!" Okay. Insoluble. Is sodium chloride soluble? Billions of little sea creatures again scream, "Yes!" Of course it is. So, number one, will you get a precipitate? What will that precipitate be made of? Yeah, you're going to get calcium carbonate in the test tube. That's what's going to develop as a precipitate. It's actually that easy. So now you have all the skills you need to do net ionic equations. Okay, so when we look at this, this one was in aqueous solution. This one was in aqueous solution. Suddenly now this is a solid. What happens to the sodium and the chloride? They're still just swimming around. They're not doing anything. They stay in aqueous solution. So they haven't really truly formed a compound. If you dried them up, you'd get salt out of it. But until you do that, it's just sodium and chloride ions in aqueous solution. And that's what we're saying here. So we, predict products and then look up solubilities. Now, we're going to recognize the fact that some ions in this whole process aren't doing anything. They're not pulling their fair share. They are spectators. Okay? So we're going to start to talk about spectator ions. Let's actually go with the example we just did. Okay? So we had calcium chloride. So we're told that we have these two aqueous solutions and we're going to mix them together. And what we want to do is write a net ionic equation for this. The very first thing we're going to do is actually take each of these compounds that we're told we have, and step one is writing a dissociation equation for each of them. So that tells us what ions are actually floating out there. So we always start our dissociation equations, of course, imagining that these things are still in solid, in a solid form. And we're going to get Ca2 plus ions in aqueous solution plus 2 chloride ions also in aqueous solution. Now we have to write the sodium carbonate, Na2CO3, solid form. Dissociate it. We get 2 moles of sodium, 1 plus ions in aqueous solution, plus 1 mole of carbonate ions in aqueous solution. That's your first step. Your second step is to imagine what compounds these would form if a double replacement reaction occurred. So we're not yet saying that it will, but if it did, and we already did this, we were just sort of doing an example. So this is pretty much a toss-off for most of you at this point. So we have that in aqueous solution, we have that in aqueous solution, and if it was going to form a compound, it would form calcium carbonate and 2 sodium chloride. Now, what we don't know about these things is their state. Of course, we do. We're cheating because we already sort of previewed that, oh, hey, one of those is soluble, one isn't. So after we do that second step, we would look up solubilities, which is sort of the preview that we just did. And we know that this would be a solid and that this would be aqueous. So our third step is to write the truth. The truth! Because what's really happening here, are we really mixing calcium chloride and sodium carbonate? No. We're mixing a bunch of ions. That's what we're doing. So what we're going to do is take these two equations and we're going to write that as our reactants, because that's actually what we're mixing together, is a soup of ions. So we're going to write Ca2+ in aqueous solution plus 2Cl1-, also in aqueous solution. Oops, screwed up. Plus 2Na1+, aqueous solution, plus CO3, 2-, in aqueous solution. That's actually what our reactants are, is this soup of ions. So now we're going to come back to here and say, well, which of those, actually let's move to a clean sheet of paper, clean page as it were. Copy, paste. Okay, if we glance back here, which of those are actually going to participate in a reaction and form a compound? The calcium and the carbonate. Sodium and the chloride are still just swimming around, not talking to anybody. So what we get out of this is actually calcium carbonate as a solid, plus, hey, we've still got our little sodium 1+ ions swimming around, not doing anything useful. And we've still got our chloride ions swimming around, not really being any help to anybody. Trying to get these things so I can fit them. Plus 2 chloride ions in aqueous solution. So this is our third step. We're almost done. The fourth step is to be brutally heartless. No, not really. But anybody who's just standing around not doing anything, we get rid of. So all those ions that are just watching the action, that don't actually do anything, those are our spectator ions. So who here is in the same condition at the end of the whole process that they were at the beginning? Sodium and chloride, they're just standing around watching. They're not doing anything. So we cross them out. And what we're left with is a net ionic equation. And so our final step, our net ionic equation, is going to be calcium 2+ aqueous plus carbonate 2- aqueous yields calcium carbonate as a solid. That's a net ionic equation. That's it. That's not that hard, is it? So I'm going to give you some practice. Okay, those 3 problems should give you plenty of practice at net ionic equations, and that's where we'll pick it up after ice cream.